Hey guys, HackerSploit here, back again with another video. Welcome back to the web app pen testing series. I know it's been a while, so we're actually going to be picking up from where we left off. So we're going to be exploring the structure of a URL, and I'm going to be explaining quite a few things that you should be aware of, right? Because whenever you're learning about web applications and, web app pen testing, you need to understand what a URL is, the various components that make up a URL, and how that will affect your actual engagements or assessments. And this will tie into bug bounty hunting, right? So hopefully this will actually come out or turn out to be useful. So what is a URL, right? So a URL or URL stands for Uniform Resource Locator. It is also known as a web address and is a unique identifier for a specific resource on a web server. Now, URLs were designed to replace IP addresses, and you might be asking yourself, well, why exactly did people do this? Well, let's use the previous example, or let's take a simple example, right? So before, guys came up with domains, right? So for example, google.com, if you wanted to access google.com or the web server that was hosting google.com based on your location, you'd need to manually type that address in. And of course, that meant that you had to actually, remember that address. And this was an issue, right? Because if I wanted to access another website, I would need to know the exact IP address of that particular web server in order to access the files or resources that are stored on that web server, regardless of whether it was hosting documents or just, simple HTML files or what we would now call a website. So this is where DNS came. This is where it actually came into play, right? So DNS essentially is like a phone book whereby, you have individuals, or you have names of individuals and their corresponding number, right? Phone number. So if you wanted to reach someone, you'd head over into your phone book, which I know a lot of people don't use now, but you typically go into the phone book, look for the individual you're looking for, and you'd get their phone number, and in this case, their IP address. So that's really what a DNS server does, right? So when you head over into your browser and you type in google.com, what happens, right? So a DNS request is made, right? And that DNS request essentially heads over to your DNS server where, your browser essentially says, this guy here is trying to access google.com. Could you please tell me what IP address I should go to or make the request to in order to access google.com? Because I'm a browser, I don't really know what google.com means. I need an actual address. And, you actually get, there's an actual response there. And, you actually get the A record if it's IPv4, or, you can also get the IPv6 address, but you get my point, right? So that's what DNS is used for. So again, very, very simple. That's why we have URLs. Now, coming back to what URLs are, or what, domains are, they might be a little bit confusing, but I'll explain top-level domains, subdomains, etc. in a couple of seconds, right? So URLs allow users to locate the specific resources or websites that they're looking for, right? So it's much easier to remember google.com, and, Google is now an actual company. So it's very clear that humans remember names as opposed to numbers. Fairly simple concept to understand. So in order to understand how URLs work and how this could potentially tie into vulnerabilities and, consequently, assessments or engagements performed on a website, you'll need to know or understand the various components that make up a URL. Now, when we talk about URLs, and I'm sure you've seen this before, you've actually seen this happen quite a lot, especially on websites that might have been set by individuals who really don't know what they're doing, or websites that have been set up by companies, right? So you'll notice something, that in certain cases, some websites don't even tell you what resource you're accessing. So if I head over to google.com, it doesn't show me google.com/search.php. That's a very stupid example, but you get my idea. Now, why is that? And that is primarily because there are two types of URLs. There's an absolute URL and a relative URL. All right. So an absolute URL contains all the components from the protocol to the parameters. So this is where you typically see, a website that has been set up by an individual who really doesn't know what they're doing in regards to, making the website look, and function relatively professionally. So you'll typically see, for example, https www.mywebsite.com /folder /login.php, and then you would pass in your parameters and values to log in. So that all of that within the URL, that's known as an absolute URL. You then have your relative URLs, which are shorter. So you typically have only the host name, right, which is going to be the actual name of the domain. So you'll typically have mywebsite.com. And, in certain cases, you might be able to access the resource. But, when you type in, mysite.com or mywebsite.com, it would essentially just take you to whatever page you're trying to access, right? And you can also type in the URL that you're looking for, or rather the actual resource that you're looking for. So, in the case of a WordPress site, if I head over to my WordPress site and then I say /WordPressAdmin.php or WordPressLogin.php, it'll display that. But when I pass in my username and password, that is not highlighted in the URL. That's because that's a relative URL, right? And that's something that is that actually ties into security, and you'll see why when we get to the practical demonstration. So what are these components that you typically find in a URL? And of course, you might already be familiar with them. So firstly, we have the protocol. So when you're typing in a domain, or you're trying to access something on the web, you'll either access it via HTTP, although nowadays that's quite uncommon. You typically also have HTTPS. You also have the mail to protocol or scheme that's used to send emails. And then of course you have FTP, right? So based on the protocol or the scheme that you're trying to, this will allow you to specify the protocol or scheme that you're trying to use in order to access the resource that you want, right? So, if I know this is a web server, I can, access it via HTTP or HTTPS. If I know it's a file server, or, I can access it via FTP, then, I can do that as well. You then have the subdomain. So this will typically be, I'm pretty sure you know what a subdomain is. Like, for example, on my HackerSploit.org domain, that's my primary site. And then I have a subdomain that essentially hosts another web application, right? Or another site, if you will. So, for example, forum.hackersploit.org. Now, typically, this will also be www. So that's, again, also considered to be the subdomain because it comes, before the host name or the second level domain. So this is the actual host name or name of the website. So Google itself, or, when I type in google.com, Google is the second level domain. Right, you then have your top level domain, which is where you have your .coms, .org, .net, etc. And then, of course, if you're in a specific region, you'd have .co.uk, whatever the case it may be. So that's your TLD. And then you, of course, have your port. Now, your port is typically not displayed if you're trying to access, for example, a web server that's running, or you're trying to access a website that's running on a web server that has been configured on the standard ports, which are going to be, in the case of HTTP, port 80, or in the case of HTTPS, port 443, then that value or that component will not be highlighted within the URL, regardless of whether it's an absolute or relative URL. However, in certain cases, individuals can configure Apache, as an example, to run on a different port, maybe like port 8200. In that case, you would need to specify the actual port, and that typically comes after the top level domain. You then have the path to the resource. So this is also known as a subdirectory. So in specific sites, like let's use the WordPress example. If I wanted to access maybe the WordPress content directory, I would essentially type that in. That's just another folder within the actual root of the web server that I can access if I have the required permissions. And of course, the WordPress admin section is reserved, or you can only be accessed after you authenticate. So, that's a fairly simple example. The resource is essentially the file that you're looking for. So when you click or you head over to a website, that's going to be the index page, right? Now, in a relative URL, that will not be displayed within the URL because, the web server is handling all of those redirects or rewrites, if you will, in the case of Apache. But again, this might be a little bit confusing, but it'll make sense once we head over into the practical demonstration side of this video. We then have the parameter and value. So if you've taken a look at, let's just use WordPress for example. when I try and log in, if WordPress has been configured or the web server has been configured to use an absolute URL, then that means it would essentially highlight that within the URL. So I would type in, WordPress login.php, question mark, username equals user, password equals password, and then login for the actual, for the fact that we're actually logging in. So that's where you have your parameters and value, whereby the parameter is, in this case, the username, and the value is the username of that particular user. And of course, you can have multiple parameters and values. Now, this diagram here, it's a bit rough because I had to sort of create it really quickly, but this highlights what I was essentially going over. So you have your protocol or your scheme, you have your subdomain, the host name or the second level domain, your top level domain here, the port, the path here to the resource. So this is your subdirectory, and then your actual resource. So for example, resource.php, and then you have your parameter and value. And in the previous slide, I used the example of logging in. In some cases, you'll also see that in the case of PHP, you'll have user IDs here. So you can now start to understand how everything fits in together. So I'll just switch over, we'll actually get started with the practical demonstration. I'm going to be using the damn vulnerable web application. I'll show you how you can set it up really quickly through Docker. And we'll be essentially exploring and seeing what happens, in the case of, specific pages and specific resources that we're going to try and access. And furthermore, once we increase the security of damn vulnerable web application, you'll actually see how this changes the actual URL and what that means for a penetration tester or bug bounty hunter. So I'm just going to switch over to my Kali Linux system. All right, so I am back on my Kali Linux system, and you can see I already have the damn vulnerable web application set up locally on my Kali Linux system. It's running in a Docker container here, as you can see. So this Docker container essentially just gives you the various logs in regards to, what requests are being made. So again, you can get this by taking a look at the vulnerables profile here on the Docker Hub and the damn vulnerable web application Docker image. A link to this will be put in the description section. So let me just turn off my proxy there. So you can access this. It's extremely easy to set up. So you can see that I've just refreshed the page. You just need to pull the image. So just pull it. It's vulnerables web -dvwa. And then you can run it right over here. Once that is done, you'll need to navigate to localhost setup.php and just create or reset the database. Once that is done, you can then log in with the credentials, admin, and password, as I've already done, I think. So, I'll just log out and show you that there. So admin and password. There we go. Fantastic. So you can see in this case, we have somewhat of an absolute URL whereby, it's telling us what resource we're essentially accessing. In this case, index.php. Let's try and play around with this. So is there a login.php? Maybe there could be. So, this is where the actual process of performing a directory or file brute force comes into play. So now you're starting to understand why we perform a directory or file brute force. We're trying to find files or resources that would typically be hidden. And you'll see that in a couple of seconds. So I'll just log in here again. This is primarily because I haven't enabled session IDs. But yeah, so, I can head over into brute force, for example, right? And in this case, looks like we have a little bit of a relative URL because we can't really access the actual PHP file, even though we are, interacting with a PHP script here. If we click on view source, you can see it actually tells us right over here. This window tells us, what we're doing. So in this case, the actual path to this particular resource is vulnerabilities brute source low.php, because we're running in the low security mode. And then you can actually see from this example here that we have an absolute URL whereby we have localhost, and in this case, because there's really not a second level domain that's not specified, and we're not going to use the IP address because I want to, again, keep it as legitimate as possible. But we have the subdirectory here, and then we have the resource. So in this case, the PHP file that we're trying to access is called viewSource.php, and then we have the parameter and the value here. So the parameter in this case is ID, and it's set to brute, and the actual security level is set to low. So again, we can't really modify this because we're viewing the source. But you get the idea. So if I head over into the actual security, you can see that it's currently set to low, right? Which is perfectly fine to get started. Now, I'll go back into brute force and I'll just enter some test credentials. So I'll say test and test. All right, log in. And you can see now within the URL here, or my actual address bar, we have the absolute URL whereby, it doesn't really highlight the resource that we're trying to access, which is low.php, but, it essentially tells us the actual parameter and the values, right? So in this case, username is the parameter, the value is test, and the password is test as well. So you can see from the perspective of a web developer why this, is really a dumb thing to do, because, again, you can pretty much play around with this from within the actual address, within the address bar. You can modify the URL, etc. But let me show you what happens here when I click on maybe impossible security, right? And I go back into brute force here, and I type in the same thing, so test and test. You can now see that we now have a relative URL, whereby even though this is an incorrect password, you can see that we have an anchor there, which again, in this context, is not really important to know what that is. I'll be explaining that. But it doesn't highlight all of the parameters and the values. Now, even with that being the case, if I intercepted this particular request, with Burp Suite, for example, you'd still be able to see it. So let's go back into low security, and let me just show you how this is handled with the requests themselves. So I'll head back over into brute force, and I'll just turn on Burp there, my Burp profile, and I'll turn on intercept on Burp here. So again, same thing, test and test, right? And we'll hit login. You can see now within the GET request, all of those components are being specified. So username, etc. Now when this is disabled, right? When the actual absolute URLs are disabled, and again, you might be asking yourself, how is this done? There's multiple ways this can be done. In this case, it's a PHP and Apache, or the LAMP stack. That's the actual stack that's being used to host this vulnerable web application. You can actually configure, Apache and enable the mod rewrite module, which can essentially, redirect you to specific URLs based on a rule set, which appears to be the case here when the security is increased. But again, this will again make sense as we progress, because from this point on, we're actually going to be moving quite fast. And in the next video, we'll be exploring HTTP cookies and sessions. So everything will start tying in together. So you can see that specified here. So I'll just forward that there. And let me just disable this for a second, and let me increase the security, right? So I'll just click on impossible there as an example, and we'll go to brute force, and we'll type in the same thing. So test and test. In this case, you can see we still have the absolute. So I'll just turn on intercept now, and let's see how that's handled. So test and test. So you can see now that that is not handled within the actual URL, right? So even though all the other fields here are specified, like the actual host or the host name is localhost, you can now see that all the parameters and values are highlighted here within the body of the request. And in this case, it's also utilizing the PHP session IDs here, which again I will go over because I know a lot of you guys were really interested in that. But yeah, I just wanted to highlight and show you what this would typically look like, or how URLs work with regards to security from both the perspective of a web developer or a company that has a web application, and penetration testers. Now, as I said, this might seem quite simple in regards to a video that I'm making, but it's very, very important. It's going to come in handy. So if we head back over, let me just set this back to low as a simple example, and I go into command injection. Let's see whether this is actually passed, as a parameter. So in this case, it's essentially provided us with a ping script. With command injection, whatever IP address I pass in here, it'll be executed with the ping command or in conjunction with the ping command at the system level. The output from that will then be displayed to the user. So I can ping 192.168.1.1, and you'll be able to see that it'll display the output of that. Now, an attacker, and I'm not going to go over command injection right now, it essentially involves leveraging input fields like this with OS command injection capabilities and sort of terminating a previous command and then injecting your own code or commands that you'd like executed. So I could say, for example, ID, that'll display the user ID, for my current user, as well as the group ID and the actual groups itself, the group's information there. So you can see that that's not highlighted in the URL. If we click on the source here, you can see security is low here, which makes sense, and you can get an idea as to what this script, this PHP script does. The script is under exec source low.php, right? And that means if we try and access this resource, if we say source low.php, let me just get rid of that there. I just want to show you something. You can see that this PHP script is not being executed, right? When we try and access it from the absolute URL, right? Or when we type in the absolute URL. Now, why is that? That is because the web server has been configured to operate in this way. And this is a security feature that firstly, again, in this case, it really isn't useful because, we've already viewed the actual source of that script, of the load.php script. And of course, if we try and we try and pass in any particular parameters like, for example, ping and the value, you can see it's not going to be executed. And in this case, no output is generated. So, I just wanted to go over that and explain that really quickly. So, that's really all that I wanted to cover. As I said, the slides pretty much explained everything. And as we progress, you'll actually see the actual the reason why I actually wanted to cover this before we actually progress. Now, in this context, what's preventing us from seeing the actual PHP file? Because I know that's a question that you guys will actually ask. If you take a look at the source code of the damn vulnerable web application on GitHub and you click on the htaccess file, let me just reload that here. You can see the htaccess file here. It should actually highlight what's going on. If I can actually find it, there we are. So you can see in this case, the PHP flag allow URL fopen is currently disabled, or it's commented out. Now, this particular flag here, the allow URL fopen, when it's enabled, it essentially means that you can access the contents of a PHP script, right? And if we enabled it, or we got rid of this comment, then we would be able to access that particular resource, through the absolute URL, and consequently, through the URL itself, pass in parameters and values if we wanted to. So if you're setting this up from source, or you want to host this on your own LAMP stack, then you can, again, take a look at the GitHub repo. You can modify it as needed. But in this case, it's really not useful because, again, I just wanted to highlight how URLs work and the structure of a URL and the security implications, when certain aspects of a URL are not displayed. And that all ties into absolute and relative URLs, And, from the perspective of a web developer, that's very important. So, on sites, on professional sites, you'll never be able to see the actual, for example, the actual script or the resource that you're trying to access, although in some cases, that is necessary, but you get the idea. So that's going to be it for this video. Thank you very much for watching. If you have any questions, leave them in the comment section down below. If you want to reach out to me, you can do so via Twitter or the Discord server, the HackerSploit Discord server. The links to both of those are in the description as well. By the way, we've actually revamped the forum. I really like using the forum, primarily because I can have really proper discussions with you guys. So if you have any questions or queries, you can definitely head over to forum.hackersploit.org, post your question there, and there's tons of helpful guys on the forum who will actually help you out. And I frequent the forum on a daily basis, so I'll respond to your questions there. I like the forum because there's a historical record, and that particular forum post will be saved for other users who have the same issue. So I have, I've answered tons of questions on the forum, and if you're ever looking, for a particular answer to a question, always check the forum because, there's a good chance that it's already been answered. With that being said, thank you very much, and I will be seeing you in the next video. I just want to take a couple of moments to thank our Patreons. Thank you, Michael Hubbard, Dustin Umpress, Jerry Speds, Doozy, Sid Saab, Ryan Carr, Shamir Douglas, Jojo Bibi, Palangos, Kushkev, RS, Nino Buikov, and David Bricker. You guys are really awesome. Thank you very much for supporting us, and you guys make these types of videos possible. So we really appreciate it, and we look forward to producing even more high quality content.